Place value is one really a topic where it's so important to pay attention to those details in how students are thinking, what they're showing you, what words they're using, what gestures they're making, in order to get that information about what they do understand, and remembering all the while that the child's perspective on this topic is so very different from yours.
In this module, we are going to tease apart 5 different ways that children conceptualize two-digit numbers. This framework draws on the collective findings of multiple research projects and is reported in the 1997 article by Karen Fuson and colleagues in the Journal of Research in Mathematics Education. So children initially see two-digit numbers in very much the same way that they see smaller numbers, as a collection of ones. Take, for example, Oliver and his way of determining the quantity of 35 cubes. What I want you to do is just tell me, how many cubes are there? The first step to understanding the quantity 35 is being able to count 1 by 1 to 35 such that each object is counted exactly one time. Then a child needs to understand that the last count, 35, is the number that describes the quantity of the set. So, can you
35.
I think we have some good evidence in that video that Oliver's definitely thinking about 35 as a group of 35 ones.
And Oliver clearly has some good strategies for counting. He knows the number of words, and he's using one-to-one correspondence and separating the cubes he's counted from the ones he hasn't yet counted.
And so next I asked Oliver to write down the number 35 on paper, and he was able to write the numeral 35. He had that connection, but that this set of cubes is 35. But then I asked him to tell me what the digits 5 and what the digit 3 meant, and he just wasn't sure.
Don't draw on it, she just fix it on this one if you don't mind. Yeah, those 2 squares should change.
No?
Okay. How many small squares are touching here?
Does this part of the number have anything to do with how many cubes you have? No, you're not sure?
And this is really typical. He's a first grader. So when he sees a set of 35 ones and writes the number 35, the 3 and the 5 don't hold any separate meaning for him.
Right. This set of cubes is 35 ones. It's a single set of 35 ones. So then at some point, children start to notice that in that number name 35, that there's the 30 part and there's the 5 part. And so they start to notice that in their numbers, that there's this part that can be 30 and this part that can be 5. And maybe that has something to do with those digits in the number 35.
So it is tricky for kids to think about this 3 as 30. Even as they're making the connection with the number word and they can tell you that the 3 represents 30, they sometimes struggle to associate that with the 30 cubes in the set.
Thinking about the times when you ask kids to write the number 35 and they write 35 like this. Have you guys seen that? I think it's really common, and we sometimes grumble or have concerns when a kid writes 35 that way, but this might really have to do with what we're talking about beginning to recognize the 30 part separate from the 5 part in this number.
Right, and they're really thinking about 35 as 2 sets of ones, as 30 ones and it's 5 ones. And it's actually quite significant because that opens the door to thinking about numbers being broken apart in other ways.
Like in tens.
Right, exactly. As children have more experiences with two-digit numbers, they develop 2 distinct ways of thinking in tens to conceptualize quantities: counting by tens and recognizing units of 10. Becoming fluent with both ways of thinking in tens is essential to developing an integrated understanding. A child using counting by tens thinking organizes objects into sets of 10 and uses counting by tens to figure out how many.
Word, if the 6 was the cubes in the cup
Here's the first problem. It says the teacher has 4 boxes of blue markers. There are 10 markers in each box. How many markers does she have?
Sure.
We're pretending we used to, they're just 10.
31, 32, 33, 34, 35.
When Grace counted 10, 20, 30, she seemed to be thinking about 10 ones, and then counting another 10, 20 ones, and then counting another 10, 30 ones. 10, 20, 30, but always ones.
Right, so each one is sort of, each time she counts a group of 10, then there's 10 more and 10 more, but it's not necessarily 1 10, 2 10s, and 3 10s.
From the evidence in the video, she sees each set as 10 ones, and she needs to use the counting sequence 10, 20, 30 in order to figure out how many.
Sometimes kids are capable of counting by tens, but they won't use that understanding unless they're presented with objects that are already grouped that way. When I interviewed Anton, he counted by ones on the 35 cubes task. So next I gave him 26 loose cubes and some cups. I had him put 10 cubes in each of the 2 cups and left the remaining 6 cubes on the table. With the groups of 10 already formed, he counted by tens.
Okay, you don't have to do it if you don't want to. If you want to say no, it's okay. Can you show me 2 squares on those?
Did you count that? I did 10, 20, 21, 22, 23, 24, 25, 26.
I think that Anton really shows us that part of thinking in tens is using that understanding in a situation where it would be really helpful, like in counting a large quantity of cubes.
So yeah, so just because a child knows the counting by 10 sequence doesn't mean he'll use it when he's counting a set of objects.
So the second way of thinking in tens is recognizing units of 10. So with this approach, I not only know that this has 10 ones, but I also know that it's 1 10, and I can count 1 10, 2 10s, 3 10s. This is 3 10s. And so a child simultaneously seeing those 10 ones and also at the same time knowing that that's one of something, that it's 1 10.
I've been guilty in the past in working with second graders of when they're counting 1, 2, 3, I stop and actually correct them because I want to hear 10, 20, 30. So in some ways, I've actually unintentionally kind of pulled them back from being able to use this recognizing units of 10 in their count.
Interesting.
Right, so what we want is for kids to see that those 10 ones, but also 1 10, and be able to think about it as 1, 2, 3 10s, and also that this 3 10s is 10, 20, 30. So, just because a child sees that 1, 2, 3 10s doesn't necessarily mean the child knows that it's 30. They might need to then use that counting by 10s, 10, 20, 30, to realize that that's the quantity.
It's these subtleties that are so interesting, right? Between 1, 2, 3, or 1, 2, 3 10s, or 1, 2, 3 30, like all of those things give us insight into maybe something different that a child is thinking.
So after children have developed these 2 thinking in tens conceptions, counting by tens, 10, 20, 30, and recognizing units of 10, being able to think of this as 1 10, 2 10s, 3 10s, I have 3 10s, the next step, where we want them to go now, is being able to develop an integrated understanding that kind of toggles back and forth between those ways of thinking and being able to do it pretty quickly. So being able to think, I know that this is 30 because I see 3 10s. 3 10s is 30. I don't have to go back and count 10, 20, 30 anymore.
And that's the really tricky part. I see sometimes that students in some tasks seem to really understand place value, and then on other tasks they don't. So it's kind of this idea of now I see it, now I don't.
So I had the pleasure of interviewing a second grader named Sophia, and she showed some great thinking in tens. She provided a really strong base 10 understanding on this 35 cubes task.
35.
35. And can you tell me how you got 35?
Because there were separate 10, so I counted 1 10,
Okay.
and then I counted another 10, and then I counted another 10, which was 3, so it's 30, and then I counted the extras, which was 5.
I see just how you were thinking about that. Sophia, can you?
So after the counting task, I gave Sophia a word problem involving 4 groups of 10.
Your teacher has 4 new boxes of markers. There are 10 markers in each box. How many new markers does she have? And how did you get 40?
Because there's 4 new boxes and there's 10 in each one, there would be 4 tens and it would be 40.
So 4 tens is the same as 40 to you, is that right? I see.
Notice that Sophia, she knew 40 right away. She didn't need to draw anything or write anything down. She just knew it was 40. So I gave her a different word problem.
Your teacher has 30 pretzels. Okay, like a big bag of pretzels, you know? She's going to dump them all out. And she wants to put the pretzels into snack bags so that there are 10 pretzels in each bag. So she's going to get some pretzels, put 10 in this bag. Get pretzels, put 10 in this bag. How many snack bags can she make?
There are 10 markers for dogs. How many markers does she have? You want to do it and you can use supplements here. Okay.
Are we going to use those in
If you would like to, when they hear, we're going to do some story problems. So if you hear the story problem and you think that these would be helpful or you'd like to use them, you can. Would you like to use those in your problem? Do you use all of those in your problem?
3.
When I gave Sophia the word problem about markers, the 4 groups of 10, it was tempting to assume she had an integrated understanding of tens and ones because of the way that she solved that problem. However, once we gave her the other problem, moving the 30 pretzels into bags that hold 10 each, we got some evidence that maybe she doesn't have quite such an integrated understanding, with the fact that she drew 10 ones for each one of those and did that 3 times and needed to count those to determine that it would be 3 bags.
Right, she's got that understanding that 4 tens is 40 or 3 tens is 30 probably, but thinking about it the opposite way, thinking about it as having how many tens are in that 30, she just wasn't quite there yet. She needed to count it out.
That's right.
So it just shows us how complex thinking about these different ways of thinking in tens and ones, how complex it is for kids, and how it really just takes a while to develop that integrated understanding.